Let us now learn the most common and the fast problem solving technique for inequalities. Okay, the name is quite fancy, wavy curve method. Now, if you have understood the previous video where we had discussed the shape of the polynomial functions in detail and the importance of roots, you would easily connect with each and every step with this method. Okay, what I have done is I have written down the various steps that one should follow to solve an inequality based on wavy curve method. Okay, let's go through it first, and then we would take up a simple problem and explain each and every step of this method. Okay, things would get complicated after that. So we would be solving a number of problems thereon, but most important step, let's understand the steps. Okay, first step. What I am saying is we have an algebraic inequality. Express it as a polynomial inequality. That's the first step. You might be a little confused. Okay, let me explain. Let's say you have an inequality something like this, x minus 2 by x minus 3 greater than 0. That is, you have to find out the values of x for which this equation x minus 2 by x minus 3 is greater than 0. This is not a polynomial function, right? This is a general algebraic equation. What you have to do is you have to express it as some form of a polynomial function. How to do it? I would explain. I would explain soon. It's very easy actually. I would explain, but you have to be careful. In fact, you can use your high school mathematics knowledge to convert the algebraic equation into a polynomial equation. But of course, we have to remember certain points, some common sense. Common sense is not always common. That's the problem. But once I explain you the step, you can do it very easily. Okay. So this is a very important step, and I would talk a lot on this step when I take up one problem at a time. Once, the second step, once you have got the polynomial inequality, the polynomial function can be factorized. So the next step is to factorize this polynomial function into this form. Okay, you might not get always x minus alpha 1, x minus alpha 2. You may get also x square minus something, whatever it is. Factorize it. That's the second step. Now, once you have factorized, there may be cases where the factor is something like this. Let's say you have a factor which is 3x minus 2, or let's say you have a factor which is 3 minus x. This can be a factor of the polynomial. The third step is to change the coefficient of x to 1. This is very important. For example, you can change 3x minus 2 to x minus 2 by 3, or 3 minus x to x minus 3. Of course, there will be a minus sign outside for the second case and a 3 outside for the first case. But you have to do it. Why? You would understand once I start solving. Now, once you have changed the coefficient of x to 1, then find the roots. That's very simple to do. The roots next is to be plotted on a number line. If you remember the previous class where you had drawn the, let's say, the cubic function, you had seen that the roots occupied certain position on the x-axis where the curve had intersected the x-axis, and the function had fluctuated between positive and negative depending on that root. So plot the roots on a number line and divide, based on that, divide the number line into positive and negative zones. those zones would give you the solution to the inequality. Let's take an example, okay? I would explain the steps, each of these steps. We would first solve a very simple polynomial equation, not get into algebraic equation, in generalized algebraic equation to start off. Let's take this, okay? Let's say you have this inequality to solve. 3x cube minus 20x square plus 27x minus 10 greater than 0. Okay? This is the inequality that you have to solve. So what is the function? The function is the polynomial function, which is 3x cube minus 20x square plus 27x minus 10. It's a polynomial function. So the first step over here, express the algebraic inequality as a polynomial inequality. That's not required because you already have a polynomial inequality over here. Now, the second step is to factorize this polynomial function. Try it on your own. Take a pause on the video, try it. Try to factorize it. Since I have framed this problem, I know what are the factors and I can easily do it, okay? If you put x equal to 1, you'd see that x minus 1 is a factor of this equation. Again, put x equals to 5, you would see that x minus 5 is a factor. And finally, the third term would be 3x minus 2. I didn't stress much upon how to factorize because that's a junior class problem. You should be able to do it. So after factorization, my equation becomes something like this. X minus 1 into x minus 5 into 3x minus 2 greater than 0. That's the inequality to solve. Now, what is the next step? The next step is to make sure that all the coefficients of x are 1. See, for the first two factors, the coefficient of x is already 1. We have to change it for 3x minus 2. So what can I write? I can write this as x minus 1 into x minus 5 into 3 into x minus 2 by 3 greater than 0. What's the role of this 3? You can take this 3 to the right-hand side. Can you do it? Well, you can do it over here. Not always. That's an important point I will talk about a little bit later on, or maybe in a later video. As of now, remember. So let's say if you have an equation 3 into x minus 3 equal to 0. You can ignore this 3, right? And write simply as x minus 3 equal to 0. There is no effect of this 3 on the equality. Same over here. This 3 does not have any effect on the inequality. So you get x minus 1 into x minus 5 into x minus 2 by 3 as greater than 0. So what are the roots? The roots are, I would write the roots in an ascending order, means an increasing order. So the smallest root is 2 by 3, next is 1, next is 5. You have to plot these roots on a number line. So let's draw a number line. You can compare this number line as the x-axis of this polynomial function, of the graph of the polynomial function. Compare this, okay? So 2 by 3, let's say, is over here. 1 is over here. 5 is somewhere over here. See, you don't need to maintain this scale. What I mean is, see, if you see, the distance between 2 by 3 to 1 is much less compared to 1 to 5. That is actually true in a real graph, but you don't need to maintain that while solving the problem. I have done it just to show you, okay? So these are the roots. I have plotted them. Now, when you have plotted these roots, The next step is very important to understand. See, if the inequality is just a greater than and not greater than equal to, you may have two cases, greater than equal to or greater than. If it is a greater than, then put a circle on the roots. If it is greater than or equal to, that means x can be equal to 2 by 3 or 1 or 5, then you would need to put a dot. You would solve problems on that. There may be cases in algebraic equation where the inequality is greater than equal to, but you cannot make the root equal. What I mean, you get to understand when I solve a problem, okay? Now, I have to divide this number line into zones of positive and negative regions. Do you remember the previous class? Around the root, the sign of the function fluctuates between positive and negative. Is it always true? No, it's not always true. It fluctuates if there is one root at that particular point. Here in this problem, that is absolutely true. There is only one root 1. There is only one root 5. There is only one root 2 by 3. Had there been two roots at once, there wouldn't have been that fluctuation. In fact, a very important point. Let me make this very important point. If, let's say, there are 3 roots at a certain point, let's assume that the equation is something like this: x minus 1 whole cube, x minus 5, x minus 2 by 3. At 1, there are 3 roots in this case. Even then, there would be a fluctuation in sign. So the generalized statement is, if there are even number of roots at a point, sign of the function does not change around that root. But if there are odd number of roots at that point, sign fluctuates. This is again a very important point, okay? Remember this as of now. I would get back to it. Now here you can understand that around the roots, there is a fluctuation for each of the root. For each of the root, there is a fluctuation in sign. The right-hand most region, which is this region, okay? The highest root and the right-hand side of that root, that region is always positive. Remember this. The right-hand most zone is always positive. The next region, hence, would be negative. The next region, hence, would be positive. And then the next region must be negative. But remember, the right-hand most zone must be positive. Why is this so? Okay. Why? Think about it. I'm not going to explain. You have to think. Why is this so? If you remember this point, that change coefficient of x to 1, there is a relation with this step which makes it possible that the right-hand most zone is positive. Think about it. Now, so the function or the inequality, the function of the inequality, it's a cubic function, right? It would look something like this. You don't need to plot the function. I am plotting it just to give you a view of this function. So I have got the positive zones. This is one positive zone, and this is another positive zone. So x lying between 2/3 and 1 and x greater than 5 are the two zones in this particular cubic equation where this polynomial is greater than 0. Okay. How to write the solution? Okay. So what do I get? X must be greater than 2/3, less than 1. This zone, right? Why is it greater than 2/3, less than 1, and not greater than equal to 2/3 or less than equal to 1? Because this equation was just for finding out the regions where it is greater than 0, not greater than equal to. Also, you remember we had drawn circles around the roots. These circles. Whenever we have circles around the roots written, it must be less than or greater than, not less than equal to or greater than equal to. So here, since there are circles, why are there circles? Because the inequality contained only greater than 0. Had there been greater than equal to 0, then this would have been a dot. Here it's a circle, hence x is greater than 2/3, less than 1, and also the region x greater than 5. Now, there is an important way of expressing this in the form of sets. See, x satisfies all real numbers lying between 2/3 and 1. All real numbers lying between 2/3 and 1 is expressed as 2/3, 1. And you have to put these numbers within a bracket. If the end point is included, end point means here 2/3 is an endpoint, 1 is an endpoint. And in this case, 2/3 and 1, these are not included over here. If the endpoints are not included, then you give an open bracket around them. If 2/3 and 1 were included, then you would have given the third bracket, okay? So you can write like this: x belongs to 2/3, 1. And there is another region, right? X greater than 5. How do you write x greater than 5? See, it includes all real numbers that starts from 5 and ends at, it goes on, it ends at infinity. You can never reach infinity. So remember, infinity is always open bracket. It's never a third bracket or a closed bracket. This is also known as a closed bracket. Because you can never make a number equal to infinity. So x is also 5, infinity. And since both these regions are included, we put a U sign over here. It means union of these two regions. So this is the solution of this particular inequality. This function 3x cubed minus 20x squared plus 27x minus 10 greater than 0 is satisfied when x lies between 2/3 or 1. 2/3 and 1 are not included, open bracket, union 5, infinity. 5 is not included. Okay, this is the solution. Now, there is a homework for you. Try it before you come for the next class. Let's say I have this equation, x minus 1, x minus 5, and 2 minus 3x is greater than 0, or let's say greater than equal to 0. You have to solve this equation. You have to solve this equation to find out when it is greater than equal to 0, or when this function is greater than equal to 0. Try it on your own. Before ending this class, I thought of doing one thing, which is actually show you how this polynomial function looks like. Plot it, okay? Let me show you the plot of this equation, okay? Here it is. This is the plot of the function, okay? It's a cubic function. It crosses the x-axis at 3 points. Can you identify the 3 points? Of course, this is 1, correct? This is 5. Here, the points are little close, 1 and 2 by 3. So that's why it's a little difficult to visualize. You can actually zoom in, okay? If you zoom in, you can see. Can you see that? Now, it's a little better viewed, right? 2 by 3 and 1. And here it is 5. And how does it change? How does it change sign? Here it is positive, here it is negative. In between here, it is again positive and negative. Very similar to the way we plotted it, correct? These things should remain in your mind.